What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet. And what we're going to be doing in this video is calculating probabilities from verbal descriptions using two-way tables. If you're just getting here now, make sure you go and check out my latest video on calculating conditional probabilities using two-way tables. Almost everything that we do in this video is going to involve a conditional probability, so it makes sense that you watch that video before proceeding any further through this video. But for now, let's jump right into it. I want to start this video with a definition, and that definition is the complement of an event. A complement of an event is the other outcomes that complete the sample space. The sum of the probabilities of an event and its complement must equal 1. The best way to describe this is probably to give an example. The first example is when flipping a coin. If one probability I have is the probability of heads, the complement of that event is the probability of tails. That's because those two events fill up the sample space. It's either heads or it's tails. Here's another example of an event and its complement. Think about when rolling a die. If I talk about the probability of rolling a 1 or a 2 on a die, the complement of that is the probability of rolling a 3, 4, 5, or 6. It's the other outcomes. And of course, when you add the probability of an event and its complement, it always equals 1. Here's one final simple example. I could say, what is the probability that the New York Giants win the Super Bowl? The complement of that event would be the probability that the Giants do not win the Super Bowl, because that is all of the outcomes in the sample space. The reason I wanted to talk about the complement of an event is because today we're going to be setting up our own two-way tables. And when you think about the categories that exist in a two-way table, each one most of the time represents complements. For instance, think of just the probability that a student uses Snapchat. Here are the complements. It's the probability that a student does use Snapchat and the probability that they don't use Snapchat. The same could be true for Instagram. It's the probability that they use Instagram and the probability that they don't. These two events here we could consider complements of one another. And of course, each entry in the table is called a joint frequency, and the sum of these rows and columns are called the marginal frequencies. Let's look at an example. In this example here, we have a class of 26 students. 7 of those students have a cat, and 12 of those students have a dog. There are 11 students who do not have a cat or a dog. Part A, what percent of students do not have a cat? Round your answer to the nearest percent. Part B, what percent of students who do not have a cat have a dog? And we'll round that answer to the nearest percent as well. Here they gave us a lot of information, but not a two-way table, so we'll just go ahead and build our own. When I build a two-way table, I typically build it like this. I leave space for my first category here and my second category here, space for the totals on the side like so. Now let's just read the question. It says, in a class of 26 students. Well, 26 is going to be the total number of students, so I'm going to put that down here in the corner. Then it says 7 have a cat and 12 have a dog. Well, those are kind of going to give us information about the two categories. The two categories we have are cat and dog, and for each of those two categories, we want to use the complement as well. So one category might be that a student has a dog or doesn't have a dog, and the other category could be has a cat and doesn't have a cat. It doesn't matter where I was to put these pieces of information or these two different categories, as long as I have a cat with no cat and dog with no dog. But it doesn't make a difference if I was to put, let's say, the dog one's up here and the cat one's down here, as you could kind of get an idea. Now it says 7 students have a cat. Well, here's cat, and the total number of students that have a cat would be down here, so I'm going to throw that 7 down there. Then I want to know that 12 have a dog. Well, here's dog, so the total number of dog owners would go there. 12 students have a dog, and there's 11 students who do not have a cat or a dog. So no dog, no cat. There's 11 students. That goes right there. Now that I have all this information, I can fill in the rest. Well, think about it this way. 7 students have a cat. There's 26 students total. How many don't have a cat? Well, subtract 7 from 26 and you'll get 19. You could do the same up here. 12 students have a dog. 26 students in total. How many don't have a dog? Well, that's just 26 minus 12, or 14. Then I can subtract here 14 minus 11. That would give me 3. Subtract here, 7 minus 3 would give me 4. And then 12 minus 4 would give me 8. I've now completed the two-way table, so we can go ahead and answer those probability questions. First one, what percent of students do not have a cat? Well, I just want to know what percent of all students here. I see I have 26 students, and what percent of them do not have a cat? Well, here's no cat. Here's no cat, and I can see that 19 of those students don't have a cat. So that's the first part. Part A, I'll do 19 out of 26. To find this as a percent, simply divide, make it a decimal, multiply by 100 to make it a percent, and I can see that 73% of all students do not have a cat. Part B is a conditional probability. We talked a lot about those in the last video. It says what percent of students who do not have a cat have a dog. Notice I don't care about all students here. I'm not asking what percent of all students. I want to know what percent of the students who do not have a cat have a dog. So for this part, part B, I only care about the students who do not have a cat. These are the students that do not have a cat. And of those, how many have a dog? It looks like of those 19 students, 8 of them have a dog. So for part B, it's going to be the probability of 8 over 19. To make that a percent, divide, multiply by 100, and rounding, I can see that 42% of students who do not have a cat have a dog. Let's see if you can try one of these examples on your own. In a class of 34 students, 24 use Snapchat and 30 use Instagram. There are 21 students who use both Snapchat and Instagram. What is the probability that a student does not use Instagram given that they use Snapchat? First thing I'm going to do is set up my two-way table and decide what my categories are. Here I can see my two categories look like students that use Snapchat and students that use Instagram. So my first category I'm going to set up as students that use Snapchat and students that don't use Snapchat, like this. My second category will be students that use Instagram and students that don't use Instagram, since these are complements of each other. Now let's read through the verbal description and fill in the information we have. It says in a class of 34 students, that's going to be the grand total. 24 use Snapchat, so that's the Snapchat total over here. 30 use Instagram, that's the Instagram total down here. And finally, 21 students use both. So for Instagram and Snapchat, there are 21 students that use both. Now that we've filled in all the given information, let's fill in the other parts of the table. If there's 30 students that use Instagram and 34 total students, that means there's 4 students that do not use Instagram. If there's 34 total students and 24 of those use Snapchat, only 10 students do not use Snapchat. Here I can subtract 30 minus 21 to get 9. Here I can do 24 minus 21 to get 3. And 4 minus 3 would give me 1. And I've now completed the two-way table. Let's go and look at what this question asks. It says, what is the probability that a student does not use Instagram given that they use Snapchat? So this is not a regular probability. This is a conditional probability. And this word given tells us that the condition is that the student has to use Snapchat, given the student use Snapchat. So here I can see that there are 24 students that use Snapchat. Those are the only students I care about. I don't care about the rest of the class for this question at least. And it says, what is the probability that a student does not use Instagram? Well, 3 of the students that use Snapchat do not use Instagram. Well, I'm sorry, 3 of the students that use Snapchat, do not use Instagram. So let's do this together. 3 out of 24, make it a percent. We should divide, multiply by 100, and round. 13% of students that use Snapchat do not use Instagram. That's a tongue twister. Let's try another example here. This problem here reads that in a class of 29 students, 7 play an instrument and 10 play a sport. There are 16 students who don't play an instrument or a sport. What is the probability that a student plays a sport given that they play an instrument? Let's start by setting up our two-way table and figuring out what the categories are here. It looks like my 2 categories are plays an instrument and plays a sport, and for each of those 2 categories, let's include the complement. So the first one could be plays an instrument, doesn't play an instrument, and the second one would be play a sport and doesn't play a sport. Now let's fill in the given information. It says in a class of 29 students, that's the grand total. 7 play an instrument, that's the total that play an instrument. 10 play a sport, that's the total for playing a sport. And finally it says there are 16 who don't play a sport or play an instrument. So don't play a sport, don't play an instrument is this middle piece right here, and there are 16 students that do that. Now let's subtract. If 10 students play a sport out of 29 students, that means there's 19 students that don't play a sport. If 7 students play an instrument out of 29 students, that means that there is 22 students that do not play an instrument. 22 minus 16 is 6. 10 minus 6 is 4. And we get 3 for the final one. Now let's answer the question. Because I see the word given, I can tell this is a conditional probability. It says, what is the probability the student plays a sport given that they play an instrument? So here we only care about the students that play an instrument. That's these 7 students. Of those 7 students, what's the probability that they play a sport? It looks like 4 of those 7 students play a sport. So our probability here is 4 out of 7. Divide to make it a decimal, multiply by 100 to make it a percent, and 57% of the students that play an instrument also play a sport. Let's try another example. In a math class with 35 students, a test was given the same day that an assignment was due. There were 22 students who passed the test and 20 students who completed the homework assignment. There were 18 students who passed the test and also completed the homework assignment. What is the probability of the student who did not complete the homework pass the test? We have 2 categories here, and the categories were passing the test and doing that assignment or that homework assignment. We know doing homework increases your ability to pass the test because you've practiced, and we want to find what is the probability that a student did not complete the homework but yet pass the test. So let's fill in these. I know one of them is pass the test or not pass the test. I could write that as pass and fail. The next category is did the homework and didn't do the homework. Now let's fill in the information that we have. It says in a math class of 35 students, put that down in the grand total. 22 passed the test. So here, passed the test, we have 22 in the total there. 20 students completed the homework. So here, the total of students that completed the homework was 20. And finally, there were 18 students who passed the test and also completed the homework. Put that 18 there. Now we can kind of fill in the rest of the information. If we had 35 total students and 20 did the homework, 15 students didn't do the homework. If out of 35 students, 22 passed the test, we can see that 13 students failed the test. Let's see, 20 minus 18 would just be 2. 22 minus 18 is 4. 2 plus 11 is 13, and I can see 4 plus 11 is 15, so it works. Now let's answer the question. What is the probability that a student who did not complete the homework passed the test? So here, this is a conditional probability. We're not talking about the probability of all students here. It didn't say what's the probability of all students. It says what's the probability that a student who did not complete the homework. Here are the students that didn't complete the homework. There was 15 students that didn't complete the homework. And of those 15 students, how many of them passed the test? Well, 4 of those 15 students passed the test, so the probability would just be 4 out of 15. Divide to make it a decimal, multiply by 100 to make it a percent, and I can see that the probability that a student who did not complete the homework passed the test was 27%. Let's try another example. In a science class with 24 students, a survey was given to determine who played basketball and who creates art. There were 8 students who played basketball and 15 students who create art. There were 4 students who did not create art or play basketball. What is the probability that the student who does not create art plays basketball? Let's set up our two-way table. Our 2 categories here looks like students who play basketball and students that create art. Of course, we want to include the complements with each of these events. So it will be plays basketball and doesn't play basketball, creates art and doesn't create art. Let's fill in the information. It says a science class has 24 students. That must be that grand total. Let's see, 8 students played basketball. Played basketball, the total there will be 8. And of the students that create all different types of art, it looks like there was 15. So under art here, I'll put 15. It says there's 4 students who didn't create any art or play basketball. So no art, no basketball. It looks like there are 4 students. Let's fill in the table. Out of 24 students, 8 of them played basketball, which means there must be 16 that didn't. If 15 students created art out of 24 students, there must be 9 students that didn't create any art. 9 minus 4 would be 5. 16 minus 4 would be 12. 15 minus 12 would be 3. And if we add across, we can see that 3 plus 5 is 8. Let's answer the question. What is the probability that a student who does not create art plays basketball? We're not asking what's the probability of all students here, so we can forget about that 24. We want to know what is the probability that a student who does not create art. So we only care here about the students that are not creating arts. That's these 9 students. And of those 9 students, how many play basketball? It looks like 5 of those 9 students play basketball. So the probability here is 5 over 9. Dividing that, I get 0.5 repeating. Multiply by 100 is 55.5 repeating percent. And rounding to the nearest percent means that 56% of the students that do not create art play basketball. Let's try one final example. EVO is the largest and longest running fighting video game tournament in the world. At EVO last year, 3,492 players registered for the Smash Ultimate event, and 1,929 registered for Street Fighter. There were 321 players who registered for both events. If a total of 9,320 players participated at EVO last year, what is the probability that someone registered for Street Fighter given they did not register for Smash Ultimate? Let's set up the table here. So I can see my events here are registering for Street Fighter and not registering for Street Fighter. I could also have registered for Super Smash Bros. Ultimate or not registered for that event. Now let's fill in. It looks like the entire event had a total of 9,320 players. Put that down here. It looks like 3,492 registered for Smash Ultimate. It looks like there was 1,929 that registered for Street Fighter, and 321 registered for both. Now let's use these 4 numbers to find the rest. We can simply subtract to find the people that didn't register for Smash Ultimate. We can subtract from here to find the ones that didn't register for Street Fighter and complete the table as such. Now let's look at what the question asks. It says, what is the probability that someone registered for Street Fighter given they did not register for Smash Ultimate? This, of course, is a conditional probability because we see the word given. We don't care about all of the participants here. We want to know only of the ones that did not register for Smash Ultimate. So here are the ones that did not register for Super Smash Bros. Ultimate. And what is the probability that of these people, of these 5,828 people, what is the probability that someone registered for Street Fighter? Well, I can see that many, 1,608 registered for Street Fighter. So this is simply 1,608 over 5,828. Dividing, we'll get the decimal, multiply by 100 to make it a percent, and I can see that we have about 28% here. Well, that's it for this video, and that's it for me. I hope you learned a lot about how to create your own two-way tables when given a verbal description to find and calculate different probabilities. Until next time.